Cool, thank you so much for being. I'm going to be at every Open FSharp in San Francisco if I can make it. It is so nice to be here. I used to live down in the valley for 3 months back in the 90s, you know, when it was just this cute little quiet place with a few little companies down there before I actually thought the valley was as big as it could ever get back then. And it was at the peak of some boom. I thought 95 I was there. I thought it's all about to crash. And then it crashed 5 years later, 5 years off, and then it came back, and then, crashed again, came back. And it's really nice to be here. And the other thing I really love is going to .NET Fringe in Portland. I hope they have it again in Portland this year. I don't know what the plan is, but let's get a really big F# contingent at .NET Fringe. I think that conference can grow to be a major dynamic in the in the .NET community, where it's so important to get creative, interesting communities who cooperate and work together, to get people together face to face. So do go up to that. It's actually in a very similar kind of venue there, if they do that at the place it was last time. And I'd encourage you to have a look. Okay, so today I'm going to be talking about F# code I love. But the thing is, in listening to the talks today, I've been reminded that this is such an incredibly incomplete talk, and I've been saying to myself, I've really got to update it with, there's just so much F# code that I love. But being here and seeing what people have been doing with the language just reminds me of that all over again. And I'll refer to a few things that came to me as I watched the talk today as I go through. But before I start, this is freshly published today for your entertainment. fsharp.org/history. There is a draft of a paper submitted to the History of Programming Languages Conference, which only runs every 10 years. And we got invited to submit something on F#. It doesn't mean it'll make the cut, doesn't mean it'll make it through, but I've put up the draft up there. And it's a 45-page rock and roll, super exciting read. The story starts, as I tell it, starts by telling the story of the industry through the 1970s and the 1980s, Microsoft's rise to dominate the industry in the 80s and 90s. And then simultaneously on the other side, it tells the story of functional programming during the 70s, strongly typed functional programming from its first, the very first idea came that we could do a sort of strongly typed Lisp, and with Robin Milner and two other people called Lockwood Morris and Malcolm Newey back in 1970s, sitting on their DEC 10 machines in the valley here. Was part of it was done, but also at Edinburgh, and then here at Stanford, and and it traces the history of strongly typed functional programming through the 70s, and this great hope of this thing called standard ML during the 80s, and then both of these stories. They come together at Microsoft Research in Cambridge, in the world of Robin Milner and ML programming language design and OCaml and standard ML, and then the world of Microsoft sort of merged together. But both of the stories had been subjected to the object-oriented tidal wave of the 1990s. And Microsoft, of course, was hit by the tidal wave of Java, and ended up in court. And a lot of Microsoft's reputation problems kind of stem from those eras. It created .NET, it's a big story to be told there. But equally, the world of strongly typed functional programming was also hit by the world of the object-oriented tidal wave, and there were many different reactions to that. Some people went and tried to add object-oriented features to functional languages. Some tried to add functional features to object-oriented languages. Some people went and made object calculi for academic kind of exercises. Some people tried to take existing functional languages and make commercial versions of them to compete with Java, and so on. And so that's really where F# came from. That's the kind of the background story to what happened. There's a personal connection there, right back to the 1970s. I said that very first idea of strongly typed functional programming. There's a guy called Malcolm Newey was one of the 3 people who worked on that. Robin Milner, Lockwood Morris, and Malcolm Newey. And Malcolm Newey was my supervisor at the Australian National University. So I had a very good fortune to be sort of exposed right to that early history of ML. And therefore, I suppose I became part of the tribe, part of the gang, part of the people who are very committed to making sure that the idea of strongly typed functional programming could be brought to its sort of full fruition. Now, we're not fully there yet, and it's just amazing to see those ideas of strongly typed functional programming now being the core of companies like Jet, billion-dollar companies being driven by this. Roughly, there's a direct connection in the ideas that these people had back in the 70s and 80s, and its actual manifestation for clear, concise, accurate code that can solve really hard problems and at good performance characteristics as well. And so do take a read of the paper. It's only a draft. Send me lots of feedback in email, please. If you were involved in the history of FSharp, it's the early history of FSharp up to about 2011, 2012. And this is an interesting conference because there's no page limit, okay? So as much detail as we want. They explicitly ask for names and dates, and they want to get, it's really not really about telling it's really about primary source material. They're trying to collect primary source material for the history of programming languages in the long term before all of us sort of drop off this mortal coil or whatever. And so do drop me notes, especially if I've forgotten someone you know, or if I've forgotten you. I apologize, but it's not too late. We've got the first draft, second draft, and the conference is until 2020. Okay, so enough on that. Have a read of that. Okay, so so I want to talk about FSharp code I love. So sources for FSharp code I love. One amazing source is the FSharp Advent Calendar. Who here has written something for the FSharp Advent Calendar? Yes, isn't it a great thing? Okay, so everyone else, it's your turn. 2018, 2019. And it was actually started by the FSharp users in Japan. There was, I think, one of the first, or maybe I've forgotten which year this was, but I can't read it anyway. But sorry, but I guess I could press Google Translate. But so we do it as well in English, and so please do get involved. And this is your chance to say, the beautiful code you've had during the year, or it's not just code, but obviously a lot of them are. You can really capture it as a gem. For the broader FSharp community in the broader world, and if you're looking for, if you're in that kind of, oh my God, my GitHub notifications are getting me down, sort of, you want to be inspired by programming again, then just dropping back through some of the old editions and reading the entries, save them up one by one for every Friday night or something, and read your FSharp Advent Calendar. Right, so I talked about the history of FSharp. Okay, so this was this was back in the old days. We used to present FSharp like this, so I thought I'd dig out some of the old slides. On my GitHub repo, if you're interested in this sort of thing, is a repo called FSharp-presentations, which goes right back to 2004. Lots of quirky presentations in there, and I don't, so anyway, you can look at those. But yeah, those nice 2007 graphics. But we always presented it as, as the purpose of FSharp is to achieve a combination of things. They do say, what do they say in San Francisco? Great house, great location, great price. Choose any two. Yeah, and that was a joke I told when I gave that slide back then. And but yes, it did feel for a long time like, it was simply impossible to get this combination of features in a programming language. And I really do think that the breakthrough for FSharp is that we deliver all of these things succinctness, scalability, all the ones I've listed here in one package. And as well as, I mean, I kind of use things like succinctness as a code word for type inference. Instead of saying functional, I might say, well, or robust, or say statically typed, and so on. So it's fair to say, if that's the whole point, that's what I've been aiming at, that's why I did FSharp, that's what we were, right back to, through the history of strongly typed functional programming I was talking about, you know, that is the code we love. We love these key characteristics. Perhaps the big ones that are added in the context of FSharp is code that interoperates, that code where you get to reuse all the hard work of the, first of all, the .NET ecosystem, and then through type providers, a much broader idea of interoperability. And so those characteristics are code I love. But we're going back a bit simpler. Code I love is this sort of thing, that a program doesn't have to have class, etc., a big sort of infrastructure around it. A program can just start with the very basics. And this satisfies all the characteristics: succinct, expressive, interoperable. It's using .NET libraries underneath. It's performant and low bug rates, and it's well-tooled as well. You get a nice hover tip if you hover over this printf. Great. Okay, so same sort of thing. Let's go through the basics. You know, we love the pipelines in FSharp. We string them together like this. Here I'm kind of taking snippets out of the code. This is from the FSharp compiler code base. It runs all the time, every time you're doing find all symbols in Visual Studio. And there's this sort of insertion of this parallel map in here. Everything's just so great. And there's this one thing, because there's so many symbol users, you can choose that particular point where you want to introduce parallelism into the pipeline of the operation. When you look around the FSharp Advent calendar entries, it's remarkable that at least half of them are about domain modeling. You know, this is this consistent theme of you know, when people draw out what they really love. And for me, the domain was always logic originally. If you read through the history of FSharp paper, then you'll see back in the 90s, while object orientation took over the world, this little band of sort of survivors of the object-oriented tidal wave, where they were hidden away in their caves with their strongly typed functional programming languages, and we were all doing logic and verification in systems like the whole system, or Isabelle, and others. And this is the sort of representations we would be writing. We would have sort of, this is our domain, and we would do recursion, evaluation, normalization, and sort of and richer logics than this one here. But it's a domain, and it's modeled very succinctly, and I can write clear, accurate code over it, and that's great. And the fact that's why these languages were invented originally, and it's what we all do every day. It's just that our domain varies, and what we do with it varies. So this is another domain I work with every day. Well, every time I have to fix a bug or add new features. This is in the optimizer for the FSharp compiler. And we have here a representation of the information that the FSharp compiler knows about your expressions. And we can just run through the cases. And well, maybe it doesn't know anything. Maybe it knows this expression. Well, we know something else about it, which is over here, but we know that it's equal to something. So this is like, okay, it's equal to that value, and we know some more about it. Here's a tuple. We know it's a tuple, and we know some things about the elements. We know it's a record of some particular type, and the information about the fields. It's a union case of some union case reference, and so on. It's a constant, or it's a lambda. We put a tag on, and we say it's a lambda, and here's the expression, which is it. This is what we know, and this is the basis of optimization. And by looking at this, you start with that clear data structure. You can actually deduce probably what the optimizer does. Okay, it replaces, if it's got if it knows let x equal 1, it'll replace that through the code, replace it with 1. And you can say if we know it's a tuple, and you take the first element of that, well, we go through and we continue that process doing the sort of obvious range of optimizations based on this information. Okay, excuse me. But it's not just compilers and logic. We've seen many talks based around this idea of domain modeling and its application. You saw that in the Jet.com talk on the event sourcing architecture that's used. 4 cases describes the domain. Here's just some ones taken from blog entries or the FSharp Advent Calendar, FSharp domain modeling. This is just cases for a status response from a request. Here's one from Odi in Nigeria, a very clear communicator about FSharp, and it really pleases me that we have a worldwide community where people in Africa and Nigeria can also participate in that community. And this is describing the set of the structure he gets back from requests from the Apple service in descriptions of playlists in a music service. I mean, how far away is that? You've got logic and you've got playlists in a music service, but it's got still this corresponding theme that we've got a domain and we've got a representation. And of course, this theme, which is so important in FSharp, is brought out so well by Scott Wollashen in Domain Modeling Made Functional. I'd really encourage you to get that book and read it. And it's really a great contribution which extends the kind of communication that we can do about FSharp into the architecture, software architecture kind of space. And the other great book I recommend at the moment is Get Programming with FSharp by Isaac Abraham. The only thing Isaac says he regrets about this book is that it was not really updated for sort of .NET Core and the cross-platform sort of FSharp on Linux, Visual Studio Code, and so on. It's got a bit of a Visual Studio-centric kind of approach to FSharp, but putting that tooling question aside, this is really a great practical programming book for FSharp. Okay. So code I love. Let's go to the other side of things. That was all about domains and transformation. And something I've been working a lot with lately is these sort of what we call MVU architectures or view reevaluation architectures. And this is where you have a user interface, but the user interface is specified in a really interesting way, which is that it's just a function that gets reevaluated to give you what the user interface should look like. And this is used in the Elmish programming model. It's used in Elm, which is not an FSharp system, but it's a wonderful system, but which is inspiring a lot of work in FSharp. And I've got a pointer here, don't I? Yeah. Okay, so we've got a view function here, and this is Elmish code, and it's very simple to read off. We might match the text, and if there's no text here in the model, we show loading, and if there is some text, then we put a couple of buttons here, dispatching messages back faster or slower, and the text, and then ticks per update. Okay, so it's a view function. And I cannot believe how clarifying this is for writing dynamic UIs. There's a UI where the content of the UI depends on the model that's underlying the user interface. Yeah, okay, so this is very inspiring for me lately, dynamic web UI. And here we have the same thing for a dynamic mobile app UI. Very similar thing, view, model, dispatch if pressed, then show some label, otherwise show some button. Okay, fine. Nice, simple dynamic UI. Okay, just to say that a major part of my work recently has been taking that idea and making it available to FSharp programmers in the mobile space. So we have this framework called Fabulous. I was very tempted just to replace this talk with a talk on Fabulous. It used to be called Elmish.Xamarin Forms, but this is a new name. If you're interested in mobile app programming, just come and grab me tomorrow I'll be around all day, so out here, and I can just give you a demo of what it's of doing some programming with Fabulous. It's got you can also read the docs. It's a very simple getting started experience. You literally just go .NET new fabulous.templates, new Fabulous app, and then give a name to it, and you're off and edit and build with Visual Studio or Visual Studio for Mac. And you're off running in iOS and Android, and you can also do WPF apps and also GTK apps, although that's not yet in the repository, but we've got a sample for this. This is co-developed with someone called Timothy Lavery in the FSharp community, and if you want to get involved in mobile or programming or cross-platform UI programming using a functional programming approach, I'm really excited how this particular project is going. Okay, there's some eye candy screenshots of various kind of apps, tic-tac-toe or contacts app or something that's using a 3D graphics library called Erhu, and map integration down here, and you can deploy these through to the App Store. Okay. Right, there's another kind of mode of use of F#, which is just, you know, a beautiful thing, and it's this data scripting approach where you're using type providers here to map in this case, one data source. We're going to get the statistics from NuGet.org. Actually, we're going to get the HTML directly from this page, and we're going to be we're actually we're screen scraping this in a strongly typed way with a single line of code here. And this data scripting approach where you just have a whole one or more data sources at the top, and then you've got whatever it is, whether it's sort of DevOps kind of analysis of the data down below, or whether you've got machine learning or visualization and charting down below. It's just like data and then straight up end-to-end analysis of that data, and then the transition of this data scripting through to sort of production applications. Okay, so there's another variation on this, which is actually data scripting, sort of scripting, but applied to the testing approach. And I actually love this because it lets me use everything I know about scripting, but in production testing as well. So at the top, we just have this little snippet where we say #if interactive, then add in a few references at the top and maybe load a library of helpers here. Otherwise, we're in compiled mode at the top. And then each test crucially takes no parameters here. So I can actually start executing through this let ABC, let DEF. I can just go through and evaluate in F# interactive these fragments of tests, and you can actually use this to script up very intensive tests, whole test matrices in here, for loops in here to cover a whole range of different test cases, and so on. And you can do a lot of accurate, exhaustive testing in scripting mode and immediately have it ready for production, for production testing in a CI system. We use this is taken more or less directly from the F# compiler services, a component I work on, yes, we just sit here and script it. Where this sum component is F# compiler service.dll. Okay. Okay. So some people in their testing approaches, they use these kind of interesting, you might say, systems for parameterizing things. Is that you put in a test data attribute here, which kind of lists out all the test cases or refers to something else. And I don't do that precisely because it doesn't work well with this scripting approach. You know, if you're going to have a loop over a whole range of different test cases, why not just write a loop in your F# code? Okay, so you know, if I see this sort of test data attribute being submitted to the F# repository. I accept it, but I'll probably go and delete it sooner or later and replace it with a for loop. Yeah. I'm not a dictator. I don't kind of say, look, get rid of that thing, and I just get rid of it. Yeah. Okay, composition. Okay, so it hasn't. Composition sort of is something that's been a bit implicit in what we've said so far. And actually, you don't see this operator used very much in FSharp. People normally put the argument in and use that the pipe operator. As Thomas said, you don't have to use a function composition to do composition. You can just use a pipeline operator, or you can just use a let binding. Okay, but there is something very nice about seeing that the compiler is exactly this range of phases. And you can Alexa parse or whatever. Down here, CodeGen must have been able to possibly return an error of some kind, so you do this railway map, and so on. And Craig here says, this isn't fancy, it's quite fancy, it's quite nice really. He says, people get giddy smiles when they see it, and there's elements of F# code that people really, not only we love that, but the people we share our code with actually love as well, and that's a very important property. I've mentioned type providers in the data scripting, so I won't particularly go through those, but good type providers and well packaged and tested are exceptionally useful and productive items. I was just talking to Andre, you see, about use of type providers for in his programming context. He's just said it's just solved so many business problems for him, and I hear that from a lot of other people as well. Okay, so that's code I love, but not. It doesn't mean I love all functional code. Okay, so it's not the case that functional programming code, which has most of what I've gone through so far is functional programming. But that doesn't mean that functional is good. Okay, so two things I don't like particularly are these two little babies that you see, and they're very cute. They're changing curried functions into tupled functions, and a tupled function into a curried function into a. That's it. You've got to remember. Right? Yeah. Right. Changing f here is a curried function and becomes a tupled function, and this is a tupled function that becomes a curried function. But I don't like them, and you can tell that I don't like them because they're not in the F# core library. So I have seen people write this. Okay, and this is a good old .NET string compare function that's going to take two strings, and he could have written string.compare bracket s1, s2. And for some reason he thought, no, and it was, I'm going to make it into a curried thing and then apply it using curried syntax. And I mean, this is so obviously, obviously just crazy. I don't know why anyone would do this, yeah. I mean, we did have an intern at Microsoft who seemed to spend the whole summer producing code like this, and then when went to kind of to clean it up after he'd gone, just line after line after line of code disappeared until there was very little left. So yes, just don't do that sort of thing, and actually don't do this kind of thing either. Whatever this is doing, it's zipping the zipping two things together is probably okay, but I don't know, and then uncurry. Just write, if you're going to do this, then just write out the lambdas, but you could have actually used map2 here or something else, but it's just better to write out that lambda explicitly in that case. Okay, there's another operator which is in the FSharp.core library, which is the backpipe operator here, and so this is the sort of thing I have seen here. Now, occasional uses of backpipe are okay, but I don't know what this does, okay? Look at that thing. Anybody know what that thing's called? That's they say it's like the Star Wars operator or something, because it looks like a TIE fighter. when you put the two things together. But I don't know what it does, and I don't ever want to have to work it out. And whatever it's doing, I think it can just be replaced by something like this. I found this code somewhere. I think it's the same thing as that. But whatever it is, just don't do that. Yeah. Okay. Yeah. So never ever use this operator in beginner tutorial code. Okay. If it's not key to the concept that you're trying to communicate, and not key to the programming model, and if you just stop and realize that 30-40% of the people, quite a lot of people might be newcomers to FSharp altogether. They might come, say they're coming to a library like, a framework like the fabulous one I showed before, or whatever they're doing, and it will be the first FSharp code they've ever seen, okay? And there are some legitimate uses of the backpipe operator. We do use it in some places in the FSharp compiler, but it's not worth forefronting it, okay? They can learn that later. It's an advanced technique if they, but don't use it in beginner tutorial code. It's just not worth it, okay? And another rule is don't ever put these on the same line. If you've done that, you've done something wrong, okay? And we should, who's Ironide? Where's Christoph? Yeah. Can you put in something into Ironide that if those two things are on the same line, then you get a warning? Okay, thank you. Power. That's power. Okay. And even worse, I put these two things into the FSharp.core library, and I am guilty, and I would like to get rid of them, and we might deprecate them one day. And don't ever use these things, right? Their precedence is actually wrong, and they should just be deprecated. Okay. Right, so another kind of code. So often you'll see in this functional code a heavy use of what they call point freestyle. Point freestyle is code without explicit lambdas and without any lets. So you might see that to list.map, you'll take the plus operator, but you'll partially apply it to 10, which is still lacking one argument, so you're really adding the plus thing here. And then, or you might see the double an increment is to multiply something by 2, compose it with adding 1. I mean, that's quite cute. Right, but just don't do that. Okay, so don't do avoid needless use of point-free code, and just write, if you add 10, put in the argument and add 10 to it. Okay, double an increment, x times 2 plus 1. Just put in the explicit arguments. Okay, I showed an example of compile before and composition, and even that you could just put in the explicit argument and use pipelining instead. Okay, so this kind of thing. I mean, so you'll see it with heavy uses of composition equals, curry, uncurry, partial application, and so on. If you've got a team who are really into functional programming, this might not apply. But if you're a mixed capabilities team, it needs to apply. You've got to think about where, you think you can moderate this through the lens of the context that you're in. But as a general thing, I'd say this is not in itself a virtue. Excuse me. Eric Sopalis, who's here, has some really good blog posts about this. In rare cases, there can even be point-free DSLs that are actually legible in the large. However, the utility of adopting this approach always carries a big burden of proof and should not be motivated merely out of stylistic considerations, which is more or less the same as saying no and yes. Okay. Using and combining existing functions as values is okay. Okay, fine. Okay, give explicit arguments. Right, fold. There's a good article called "Fold is Considered Harmful" who's it by? It's by Guy Steele, I think. So whatever data you've got, fold, it's always going to be a blunt instrument, and it's nearly always better to replace it by something simpler. So for instance, instead of folding the plus operator with an initial value of 0, then just call array.sum, or array.sum by, or max by, or choose, or try pick, or fold, map fold, or reduce. So there's nearly always something you can replace it by that's either simpler or more specific to a particular use. If you use fold or map fold, then typically I prefer to use this pipe 2 arguments operator, this one here. So instead of writing fold function state list, you actually put it the other way around. You take the initial state and the arguments, the list of things, and you fold it through this operator to round and round and round. State, element, new state, round and round. Just to get that left to right thing going on in your code using that double thing, double argument pipelining. Okay. If you don't do this and you kind of write this kind of code, then your code is actually really hard to understand. It's like people have to mentally decode it into being a loop, and they have to. I've sometimes stared for half an hour at people's fold, and I've only understood it by effectively decoding it into simpler steps. Right, records. Okay, so records are strongly associated with functional programming and domain modeling, and that's all fine, but records can be bad. Okay, so when we design a type, we often need an external view of the type and an internal representation. Okay, so records are really, really good when these are the same. When what you put in is what you get out. And perhaps in FSharp you can also augment that by a few members that add a few more things into the record. Whenever the external view is the internal representation plus a bit more, then that's good. Records tend to be good. But if they are not the same, then records can cause you pain. Just one example of where people use records badly. I thought actually an example which illustrates this point as well as it could be. So this is sort of separate points. This is really about using records in a case with mutable data, ref here, that should be encapsulated, okay? And if you start having mutables in a record, then it's really probably a good idea to be heading towards a class. So here, a much better thing would be to let mutables here, put it inside a class, take whatever parameters at the top, and more carefully publish access to this set of mutable components. So using a record here had no virtue whatsoever. It gave you no advantage at all. In fact, the representation was very likely to leak out right across your program. And this is based on a code from the history of FSharp called, it was a system called Terminator, Static Driver Verifier, two different systems. And the core representation types were in this were in this mode, and they leaked everywhere. There was no encapsulation, okay? And they pattern matched on this thing, and they pulled out the individual mutable components and used them in a first-class way. It was very, very leaky code. And if they had gone through and tidied it up and encapsulated things properly, then things just would have been much more under control. So if your record types are not symmetric or representationally simple, then just use a class here. And be prepared, as your code evolves, be prepared to make large records private or convert them to classes. It can be a little bit painful to make that conversion step, but it's in the sense that you have to make adjustments to your code across your code base, but it's an important step to be ready to make. Which leads us to the question of objects. Okay, so we do objects. You all know what they look like in FSharp. Here we have a type and arguments, and been using this slide for a while. Inputs, internals, exported properties, and exported methods. Nice little functional object. And they're the features of the language. We have constructed class types, which we've just seen. The data can be mutable here as well. We have object interface types, and we have object expressions for implementing them. Okay, nice and good. We all know those. So a pattern that actually works really well and is actually really entirely functional is this one, where you have a class type that takes some input. This is taken from FS Lex Yak, these descriptions of these kernels here. It does a functional programming in the middle here, encapsulated, and then publishes access to those computed tables. Here we compute a table, another table here, and we publish a minimal access to that. So this is functional programming and object orientation working extremely nicely together. So yes, we like that. Okay, but object programming okay, so let's talk about object programming. Right. So in the history of FSharp, I sort of describe what we did with object programming in FSharp, which is really to deconstruct what object orientation is into lots and lots of individual features, and then look, instead of saying we need all of these things in our functional programming language, we want to take a more limited, nuanced approach. So we look at all these individual features and we say, okay, we want some of these, and we're going to be able to accept others, and there are other things that we don't want. And so over time, people have kind of said, in discussions, I've realized that's what we actually did with FSharp. And the categorization is roughly this, that some of those features make FSharp a better API language, for a better language for describing software components. So some are actually good for implementation. Some are just part of an interop standard in the world that we live in the case of .NET or Fable in JavaScript. And some really are not particularly needed when writing software at all. Okay, so where do we stand with these? So these items, so FSharp embraces the dot notation. We really like being able to do x.length. Okay, sure, we need a type annotation to know what x is, or some kind of type information from type inference, but dot notation is a good thing. It's better than writing array.length or dictionary.count endlessly as a function. We also therefore, we also embrace instance members and type-directed name resolution. Okay, that we use a type here to resolve what length means. You've seen the use of implicit construction in objects in that Alexiac example. We also embrace the use of types as static, as containers as names, so you can use static members. We have notational devices like array.x, and things like named and optional arguments for describing APIs, and subtyping for interface types and implementations. So all of those things are seen as embrace them and use them sensibly. Then there's a whole set of things which are much more like use when necessary, use tastefully, use respectfully, use sparingly. So mutable data, you use it when necessary, that's fine. Defining operators on types, patterns like idisposable and IEnumerable make a lot of sense to use. Defining extensions, structs, delegates, enums, typecasting. All of these are actually reasonable things to do in FSharp programming, but not to the extent that you would do them in object-oriented languages. Now there's a set of things here which are really going down the rabbit hole. You can do them in FSharp if you want, but they are not. They are to be outright avoided in the vast majority of FSharp code. So method overloading is one example. FSharp is very biased against hierarchy-oriented programming. Okay, probably the biggest difference between the object-oriented languages and the functional first approach of FSharp is that we really de-emphasize implementation inheritance and large type hierarchies. And obviously we strongly bias against nulls and using unchecked.default off. And then there's a set of things here which we simply are not supported in the language. You can import protected members, but you can't define them. Curried method overloads is not supported. Self types, wildcard types, and a whole bunch of other things from object-oriented programming. Okay, so putting that all together, love, tolerate, avoid, and forget, down here, you get, the way I like to talk about it is that FSharp supports object programming, but is not an object-oriented programming language. F# also supports sequence programming. It also supports async programming. It also supports modes of use like the data scripting approach that I showed. And so object programming is just one of those modes of programming. It fits pretty well with the others. So yes, that's great, but we are not object-oriented and not sort of object-first. And what's the difference? Well, object programming will focus on succinct coding, notational convenience, API ergonomics, good naming, encapsulation, small composable abstractions, expression-oriented, and crucially, and this is a very crucial point, F# object programming is about making simple things out of complex foundations. And that's very often because we use delegation instead of inheritance. If you look back to something like this, which one? Hang on, can't drive. Where was it? Sorry. No. Function on objects, this one here. Yes, so we had a simple input and simple outputs, and something complex happens in between. I mean, it's not that complex, but there are other examples from this code base where there's a lot of things happen in between. So you're making something simple by delegating to internal complex structures. Whereas in implementation inheritance, or object-oriented programming, you have objects as a single paradigm, this massive focus on hierarchical classification, animal, cat, dog, and then it goes all the way. And you often end up, the problem with implementation inheritance is you're always taking something that's already complex and making it even more complex. You can't get rid of stuff by using implementation inheritance. With delegation, you can delegate to something and control access to it. But with implementation inheritance, you can't. Okay, so the key difference here. And if your abstractions get bigger and bigger, then they end up with many holes and many failure points. So, okay, so putting that together, F# approaches to embrace object programming, make sure it fits with these other modes of programming, expression-oriented, sequence programming, list comprehensions, whatever, but not to embrace full object orientation. Okay, I haven't actually got the time. What time have we got? It's okay? Yeah. Right, okay. Just a couple of other topics to finish up on. So, mutation. Okay, so there are places to use mutation well. Again, it's about encapsulation. Here's an example of sort of unencapsulated data, just a whole bunch of functions hacking on this dictionary argument here. Add to closure table count, closure table contains, and so on. And it's just better just to make, again, the type here that encapsulates the underlying dictionary and controls access to it. Again, a dictionary here is quite a complex thing. There's a lot of things you can do with it. So it's better to hide it away and publish just a small set of controlled access to that delegated object. Okay, on the mutation side, you pretty much never need to use ref these days. So you sometimes see people creating explicit reference cells. We've done all the work in F# to make sure you don't need to do this anymore. If you have explicitly mutable locations, you can nearly always use let mutable, and if necessary, encapsulate that in a class. Give it a strong name. So repeating that, nearly always avoid the use of ref and use let mutable in an expression or a type. So you don't write this sort of thing from this old F# code, really, old style, where you'd have a mutable reference here, and then you would dereference it, and then dereference it at the end. Instead, just make it let mutable accumulator is this, use the accumulator here, and then take the accumulator and publish the result at the end. Okay, so if you use ref, I mean, hopefully a lot of you don't even know that ref really even exists in the language, so you almost never need to use it. And we had been planning, we haven't yet actioned this, it's certainly not in F# 4.5, which is done, we actually were considering deprecating these operators, bang and colon equals, and just making it that you need to write those out explicitly, either use mutable or be explicit about it. Okay, null, of course, we don't like code that has null in it. I have used it. It's used in the compiler for these cases, compact memory representations, sometimes for implementing fix-up structures, and sometimes in high-performance situations for using one level of indirection for an option type. So there's some examples of doing this, but every now and then you will see this sort of use of uncheck.default of, but really try and localize that and make sure it doesn't leak out of your code. In FSharp 5.0, we're planning to do work to make the use of null a little bit safer to match the C# work that's going on, but I still don't expect null to be a particularly big part of FSharp programming. Okay, so code I love. The computation expression feature of FSharp is absolutely beautiful. If you look through code I wrote, and also through Fable and other view model code, then the use of advanced uses of these comprehension notations for sequences, lists, and arrays is just absolutely beautiful. Once upon a time, you used to see this kind of code. Let rec all symbol in entities be list.doc, concat, filter, collect, cons, filter, and so on. And that looks like good functional code, and in many ways it is. But that can all be replaced by a single list comprehension here with explicit for loops here, and then the yielding of the elements down here. And this kind of code is really good for capturing irregular, generative but perhaps irregular kind of structures where some of these things are conditional and you've got multiple things being appended, but this kind of code is very clear and declarative for list comprehensions. Okay, the async code I love. This sort of thing looks beautiful. Take the server, client, and browser asyncs, run them in parallel, and wait for all of them to complete. I noticed that snippet and thought, well, that's just really, really nice. That's a larger kind of code here. That server is to run the .NET CLI, client, async, and then composition, and then run. So on computation expressions, there's this lovely library called FSharp control.async-seek, which I would encourage you to use. And it is, they're thinking of adding this feature to C#, asynchronous iterators, but FSharp already has the feature and we should make more of it. It's used a lot at jet.com. And Lev Gorodonsky is from jet.com is a co-maintainer on this library, and allows you to write this sort of reactive code where you sleep for a while and then yield a result, and then sleep for a while and yield another result. You can take async sequences and turn them into iObservables and turn them into all the other sort of manifestations of similar concepts. But you know, this is lovely. Yield a thing while true, sleep, yield another date. And this just yields a sequence of timestamps. Okay, and yeah, a lot of difficult streaming problems look really nice in this coding style. And these computation expressions, which are around the community, they're not in the FSharp core library, but which combine async with options, can result in really nice code as well. So they're not something we put into fsharp.core, but we should really actually, we should be using these things. Okay. So I was particularly amazed to see Vasily Kirichenko's code in the fsharp.editor implementation, which uses this to really eliminate a lot of complexity from that implementation. Because I'd implemented similar code and it was full of cases dealing with optional results, and he was able to use these sort of things to really clean up what we'd been doing. Here's some examples of that. When you're working in the tooling, Ionide or in Visual Studio, Your simplify name diagnostic analyzer is using that async maybe, and you can see, guard under some setting, do the trace, sleep for some initial delay, do the parsing, look up a cache, and then map the result at the end and start. And it's very succinct code that captures a lot of conditions where things might fail along the way. Okay, I'll skip over that. I love the use of computational expressions for these sort of advanced composition languages, Freya Machine and Saturn Scopes and others, where you have a scope here and then sort of declaring the contents of the web handlers. We didn't design computational expressions for this kind of application, but it's a very general mechanism and is, shows how powerful the mechanism is. Okay, just to finish off, don't forget that your code has to be, I love code that can be debugged. Your code should be commented. Your code should be properly tested. I spend a lot of my time making sure that the work I do is under continuous integration in the GitHub repositories, doing the performance tests on it, and above all, just making sure your code is readable and captures the intent of what you're trying to do, and is readable by newcomers to the language, and doesn't expect too much of people coming to your repository. So for instance, implement toString and debugger display on your types to make sure your code can be debugged. Make sure you use proper good variable names, good method names, good stack traces, comment your code well. Okay, so as I've been explaining, FSharp is absolutely full of just delightful moments, beautiful coding fragments, and there's an experience that some programmers have that programming can be difficult because you're always in the wrong. You're always making mistakes. You're always struggling with bugs, and the gratifying moments can be few and far between. But I think one of the things that makes FSharp such a great language is that people get more of those gratifying, happy moments as they're using the language, where their code matches their intent and captures something beautiful about the coding that they're doing. And so I hope that's true for your coding, and try and make it true for people reading your code as well. Not all functional code is good. Functional programming can be massively misused, so be careful with it. And it's obviously the same is true for object-oriented programming. And I would like to use this as a kick-starting discussions about coding standards. Philip Carter here has taken over the FSharp coding style guide, and it's now part of the Microsoft documentation about FSharp. So please, it's absolutely critical to read that, get a sense, is it suitable for use by your teams? Okay, do you agree with it? And if you have a team, start with that as your baseline, and then iterate from that to make sure you have an agreed style guide as a team. Okay, and that's all I have to say, and I enjoy your FSharp programming. Thank you. Okay, questions? Who's first? Yeah.
One thing I missed from Haskell, and I don't know if FSharp maybe it hasn't now, but in the past it didn't. I missed the $sign operator and the ability to find a precedence when you find an operator.
Yeah. Okay, so to repeat the question is that Haskell has a $sign operator, which is, if I remember rightly, is like the pipe operator in FSharp, or is a backward pipe operator.
No,
it's the.
It's like a way of getting rid of having closing parentheses.
Yeah, it's backpipe. Yeah, it's a backpipe operator, but with a different precedence. You see that I'm not a fan of the FSharp backpipe operator, which has the wrong precedence as well. Luckily. Yeah, because I don't like don't like it. So I don't like the dollar operator in Haskell. I think it. I know. I get why people use it, and it's used in Haskell, and I respect that in it. But I don't want to have the dollar operator in FSharp because minimizing parentheses is not an aim in itself. I do see people using the backpipe operator just to get rid of a few parentheses, but it's not. It should not be an aim in itself. The parentheses actually make code more readable in many cases. So in general, looking at Haskell code, the vast majority of uses of the dollar operator can just be made into forward piping. Okay, so you simply pipe forward through things. There are some cases where people use the backpipe operator, but you just be explicit about putting the parentheses in. And then there's rare cases when the backpipe operator actually is kind of useful. Okay, when you bind and have another big block of code. There are places we use it in the compiler. So, okay, the other thing you asked about is defining the precedence of operators. FSharp doesn't have that, and that's by design because it's like a lot of those things. It gets misused more than it gets used well, and that in order to comprehend the code, you have to go look up a set of the precedence table, and it's, precedence tables aren't easy to mentally digest. You've got to keep saying, well, how does this actually parenthesize and so on. And so it's really deliberate that we don't allow people to write that kind of code, just for readability concerns. Yeah. Next question? Yeah.
So FSharp has three primary use of representation types. You have tuples, records, and unions. Is there much
and objects.
And objects.
Yeah. Okay, so the question is, we've got three primary ways of defining types. You can define a record type, you can define a union type, or you can define a class type. And should this be unified more than it is? So. The thing where I would agree most with that is that the transition from record types to class types, I alluded to it a bit, is a little bit rocky. As you get rid of the use of a record type, especially if you want it to continue to be a functional class type, then you have to write a little bit too much boilerplate, perhaps. And especially if you've used the with syntax with records somewhere in your code, then you have to remove the use of that. And we've been through that loop with Avi Avni in the FSharp compiler. That it was quite a lot of work to get rid of the use of some record types where we wanted to hide the representation because we needed the representation to be more compact. We needed to use encoding for things. There are other places where we have unified things. So, for instance, a decision to be able to have members on records and unions, to be able to define new instance methods in terms of the record and union. This is how we unify things. But we did make a deliberate decision to keep records and unions as separate things, particularly because, records and unions both have the property that what you put in is what you get out. They have this symmetry to them. And that allows us to automatically generate the hash code, the equality, and the comparison logic for those types. And we don't automatically do those for class types, where you don't know, is your equality with respect to the external representation or the internal representation? And you have to be really explicit about that in class types. So that was the main reason we wanted to keep those separate, because, I think that's a good decision, how we made that separation. Yeah.
What is your opinion for using CLI mutable versus class type?
Using
CLI mutable with records versus class type?
So FSharp has a feature that you can attach an attribute called CLI mutable to a record, and that makes it the actual underlying .NET representation of the thing mutable. That's only for use in particular situations, particularly when you're working with a library, a serialization library, or something, some reflection library in .NET, which needs to mutate those in order to construct those objects. Okay, so that's the only situation you should really use CLI mutable. If you're doing any mutation in your own FSharp code, of course you should be explicit about it, and either put mutable in your records, or as I said, switch to a class type. Yeah. Yep, Jack.
What are your thoughts on the present and future of statically resolved text?
Okay. So that's covered to some extent in the history of FSharp paper, which is not just a kind of a telling of the story of the people involved, but actually goes through the technical features of FSharp, especially FSharp 1.0 and 2.0, and where they came from and why they were done. Statically resolved type parameters were added, and along with inline code, to get fast generic arithmetic over a range of numeric types. Okay, and they have a whole range of other applications, but that's really why they exist in the code, that you can inline the code, you can eliminate the use of all the arithmetic operators, and generate fast code out the end. Now, people do use them as a replacement for type classes, and you can do that, but it's deliberately fairly obscure to do that, and I don't particularly encourage that. I would probably put it in code I don't love. Okay. The mechanism is also fairly fragile in the compiler. Okay, so I would like to evolve it in the language, and to make it a kind of limited kind of type class mechanism, but it is fairly fragile in the compiler in that you got to be very careful how you change the logic that does the resolution. And in particular in FSharp 4.0, we accepted a couple of pull requests which adjusted that logic, and we paid quite a big price for that in bugs or changes in behavior which we hadn't properly predicted. And so the mechanism fits what it was designed for very, very well. FSharp has generic arithmetic, but is implemented at full performance. Okay, and very few languages have that. I mean, Haskell has type classes, but it's extremely easy to get very slow code out of the use of that, where you get boxed representations, or type classes don't work over unboxed representations or whatever. So that's where we're at with the feature. Does that make sense? Okay. Yeah.
I was always curious, in FSharp, there's a try and lit, and there's a try and finally.
Yep.
I was always looking for a try with finally. Was there any...
You simply nest them. So the question again was, try with and try finally exist in the language, but some object-oriented languages allow you to do try with finally. But in FSharp, you simply nest them. You do try with, try finally around a try with. So because FSharp the nesting is just quite natural, this is, I think, actually clearer to what's going on. And particularly it's clearer for the case where the exception handler itself raises another exception. It's very clear that the finally gets run. So I'm happy with just making people nest that kind of code. I think it's clearer. Yeah. Yeah. Okay, last question. Yep. This was about name of and string interpolation. Yes, both are accepted as design items, and we have had partial implementations of those through as pull requests, but I absolutely want to do both of those features. They're totally on the roadmap, and they to the extent the roadmap has, in the sense of approved in principle features, and people have gone a long way down the line of implementations. But for various reasons, we've never landed a final version of those features in FSharp 4.1 or 4.5. But please help us refine the RFCs and refine implementations and get them fully tested and get them, we can't put in anything that's not fully tested and completed, when nothing's going into master that isn't finished. Okay, so we've let's do that together. Okay, thanks.